All right. So here we are at TryHackMe, pre-security, how the web works, DNS in detail, task 4, making a request, right? Just to let you know, this is all written by somebody that has no idea how to talk to newbies. And and you know what? By experience, I have a very good feeling if we were to say, explain this to us like we're idiots to Gemini or anybody or any LLM, it would probably say the exact same stuff because nobody has actually ever broken this down as if they're talking to 10-year-olds. You know what I'm saying? So get ready. Anyway, so what happens when we make a DNS request? Oh, here we go. So when we request a domain name, our computer first checks its local cache to see if we previously looked up the address recently. Okay, so it looks in the local cache to see if we've already looked it up, right? If not, a request to our recursive DNS server will be made. So there's this thing we're going to go into right now called a recursive DNS server that it's going to look up. So the first step is looking inside of our own computer to see if the local cache has the address. And if not, we'll go to this thing. So a recursive DNS server is usually provided by our ISP, but we can also choose our own. Okay. So it's basically, this is a server that the ISP has on hand. So this server also has a local cache of recently looked up domain names. All right. So if other people, I imagine that's if other people have already looked it up. All right. So if the result is found locally, it's sent back to our computer and our request ends there, hopefully. So this is common for popular and heavily requested services such as Google, Facebook, Twitter. I'm sure there's a ton more because I mean, the ISP in the area serves a lot of people and they go to a lot of websites. You know what I'm saying? Anyway, let's keep going. If the request cannot be found locally, a journey begins to find the correct answer, starting with the internet's root DNS server. Okay, so if the address is not found here, we're going to go and do a search over here. All right, so the root servers act as the DNS backbone of the internet. Their job is to redirect us to the correct top-level domain server. All right. So there's root servers somewhere on the internet that this is their job to, if this one doesn't have it and this one doesn't have it, there's servers that have it somewhere, according to this, depending on our request, of course. If, for example, we request tryhackme.com, the root server will recognize the top level domain of .com. All right, it'll recognize .com here and refer us to the correct TLD server that deals with .com addresses. So somewhere out there on the internet, there's a server that's full of all the .coms. That's where it's going to look it up. All right. So the TLD server holds records for where to find the authoritative. Whoa. So yeah, now we're on this authoritative one, whatever that is. All right. So the TLD server holds records for where to find the authoritative server to answer the DNS request. Okay. So the authoritative server is often also known as the name server for the domain. Okay. For example, the name server for tryhackme.com is kip.ns.cloudflare.com and uma.ns.cloudflare.com. So I guess Cloudflare is the website that owns it, kind of like GoDaddy owns some and whatever other ones own others. I guess that's what the name server means. So we'll often find multiple name servers for a domain name to act as a backup in case one goes down. Okay. An authoritative DNS server, this one right here, is the server that is responsible for storing the DNS records for a particular domain name and where any updates to our domain name DNS records will be made. Okay. So all the records are going to be on this authoritative thing, according to that sentence right there. So depending on the record type, the DNS record is then sent back to the recursive DNS server, where a local copy will be cached for future requests and then relayed back to the original client that made the request. Okay, so once it's found in the authoritative or here in the root server, it's going to come back up here. It's going to be stored on your computer and it's going to be stored in the recursive DNS server, right? So that it doesn't have to go through this crap again twice. All right. Okay, DNS servers all come with a time to live value. Okay, this value is a number represented in seconds that the response should be saved for locally until we have to look it up again. Right, so I guess every one of these has every one of those like lookups has a timeout on it, I guess, to save space, just in case it's like a one-time thing and you never need to go there again. I guess that's what it means. So caching saves on having to make a DNS request every time we communicate with a server. True. Yeah, because we don't want to go here every single time when we could just go here or on our own computer, right? Makes sense. So what field specifies how long a DNS record should be cached for? All right. So that's going to be this time to live value right here, because it's the only thing it was talking about time. So TTL, let's check it out. Come on, come on, come on. All right, good. What type of DNS server is usually provided by our ISP? All right, so we know that was the recursive DNS server that's provided by the internet service provider. So let's do that. Recursive. There we go. Yeah, all right. So what type of server holds all the records for a domain? All right. And so we got that one on authoritative, which is, where does it say especially all? I know it's this one because it's not this one. But where does it say all? So this is responsible for storing the DNS records for a particular domain. All right, cool. So authoritative. Authoritative. Right? And submit it. All right, so that wasn't too bad. All right. So now we're on to task 5, practical, and we'll see you next time.